Hello and welcome everyone. In this video, we will learn about list comprehensions and generators, both of which help us write cleaner, more efficient code in Python. So let's get started. Let's begin with list comprehensions. List comprehensions are a concise way to create lists in Python. They make your code more readable and are usually faster than traditional for loops. That means instead of writing multiple lines with loops and appends, we can create lists in just one line using list comprehensions. So guys, here is the syntax of list comprehensions. First of all, we assign a name to the list that we are creating. Then we assign it a pair of square brackets within which we mention the expression which represents the operation that you want to apply for each item in an iterable. Here iterable represents a sequence of data, for example a list, tuple or a range. And then at the end we mention if condition. This if condition is optional and is used to filter out items that meet a certain condition. Let us see an example. So guys, I am inside PyCharm IDE and here I am going to show you how to create a list of squares from 1 to 10 using list comprehensions. So let us give our list a name, let's call it as squares, and we will assign it a pair of square brackets like this. Now inside this pair of square brackets, we are going to mention the expression that we want to apply on every number from 1 to 10. So let us suppose my value or number is represented by x, then I want it square, which should be represented by double asterisk symbol followed by 2, that is x raised to power 2. Now I want to apply the same operation for every item or for every x in the range 1 to 10. So I will mention here 1 to 11 because 11 will not be included and I want the square to be displayed for every number from 1 to 10. That is why I have to mention 11 instead of 10 at the end. So this will generate my list of squares and let's print it. Here don't forget to choose the current file before running and now press run button and you get a list of squares. So square of 1 is 1, square of 2 is 4, square of 3 is 9 and so on. Now let us suppose that I also want to apply a condition on this list that only the squares of even numbers should be displayed. Then inside this pair of square brackets only, I will mention if condition at the end like this. So my expression will be that if the number is divisible by 2 and gives remainder 0, then it is considered as an even number and only then its square will be generated and stored in this list squares. Let's run this program. And here we get squares of only even numbers from 1 to 10. So square of 2, 4, 6, 8 and 10 are displayed on the screen. Okay everyone, let's put this code in comment and I'm going to click on code and comment with line. So let's shrink this also and let's move on with our next example. Suppose this time I am having a list of fruit names like this and I want to extract the first letter of every fruit name. In this case, let us call this list as initials and in order to extract the first letter, I will mention the fruit name and I want to extract its first letter. Since every fruit name is a string, so the first letter of a string is always stored at index value 0. This fruit is just a generalized variable for every fruit name and I am extracting the letter at index value 0. So this will happen for every fruit inside fruit names and then I will press enter and print here initials. Let's run this code and this time I have got the first letter of every fruit name in the fruit names list. So here you can see A for apple, B for banana, M for mango and so on. Alright, let us suppose that I want to extract only those fruit names. Now I am talking about complete fruit names whose name begin with G. So in this case I don't want the first letter, I want the complete fruit name with the condition that fruit name begins with letter G. So G should be written inside double quotation marks. Let's run this code and this time we have got only two names, guava and grapes. We can also create nested lists with list comprehensions. Suppose that I am having two lists. Let us say the name of the first list is letters and it contains only two letters, say A, B And my second list is called as numbers, having three values 1, 2 and 3. Now I can create a nested list from both these lists using list comprehensions. And suppose that inside that list I want to store pairs of values from each of the above lists. So let us suppose the name of this third list is nested list, and it will contain a pair of values from letters and numbers. So let us suppose X is the value from letters list, followed by Y, which is the value from numbers list. Then outside this pair of inner square brackets, I will mention for X in letters, for Y in numbers. And that's all. Then I will print here nested lists. And let's run this code. Just choose the current file before running. Now run it. And here we get A1, A2, A3 followed by B1, B2 and B3. So here you can see how we can combine two lists to create pairs of values from each list. We can also store these pairs inside tuples. Just change the bracket from square bracket to round bracket. So here we have made the change, and let's rerun the code. And this time we have got tuples inside our nested list. Alright guys, let us move on to discuss about generator expressions. In Python, generator is an iterable created using a function with a yield statement. So unlike normal functions where we use return statement, in generator functions we use the yield statement. On the other hand, instead of creating and storing the entire list in memory like list comprehensions do, a generator yields items one by one, making it more memory efficient. So everyone, here I have created a simple generator function that yields numbers from 1 to 3. As you can see, this function is defined like a normal function, but instead of using the return statement, I have used the yield statement, and that too 3 times. So yield 1, yield 2 and yield 3. Then in line number 8, I have assigned this function to a normal variable gen, and this is the function call statement. In the next statement, I am going to print this gen variable. Let's run this code. Choose the current file before running and then run it. And in this case, the output shows us a generator object, which is a simple generator at this particular memory location. So even though that generator object has been created, which is ultimately an iterable, I am unable to see the values. In order to get the values, I will be using the for loop like this. So for num in gen, for every number inside this gen variable, I am printing here num, and then let's rerun the code, and this time numbers 1, 2 and 3 are displayed on the screen. In Python, a generator expression is an expression that returns a generator object. It is similar to list comprehensions but is written with parentheses instead of square brackets. Let us see an example. Suppose that we want to generate square of every number in the range 1 to 10 using generator expression instead of a list comprehension. Then we will have a variable, let's call it as gen_exp, and this time we will assign it a pair of parentheses instead of square brackets, and I am saying that my expression is that I want to generate the square of every number for x in range 1 to 11, and then we will print this gen_exp, and when we run this code, in the output we get to see that a generator object has been created at this particular memory location. Now in order to see the values, I will have to display all the values using for loop by iterating over this generator expression. So I will type here for num in gen_exp print num, and then I will rerun the code to see the values, and here you get to see all the values are generated. So square of 1, 2, 3, 4 and so on are displayed on the screen up to square of 10, which is equal to 100. That means generator expression generates one value at a time, and this is unlike list comprehensions where all the values are generated in one go. In this video, we explored list comprehensions and generators, learning how to use both of these for efficient data handling in Python. Here is a final comparison between list comprehensions and generators. While creating a list, Python reserves memory for the whole list. On the other hand, a generator yields items one by one, making it more memory efficient. Second point of comparison is that list comprehensions are great when you need all elements at once in a concise list. On the other hand, use generator if you don't need to keep every item in memory. Lastly, list comprehensions are faster to run as compared to generators, which are slower in execution. Well everyone, I am wrapping up this video with a small set of practice exercises. Try to share your code with me in the comment section and also give your feedback. If you have enjoyed this video, then don't forget to hit the like button and subscribe my channel Programming Horizons. Thanks for watching and I will see you in my next video.